Hello, today's lesson is extension 3.4 in Big Ideas Math, and we're factoring expressions. So we're back to Farmer Fred and his problems. He has to build pens for his poultry, and he wants to give the turkeys 48 square feet and his chickens 36 square feet. And I'm asking you, what are all the possible dimensions of the pens? So now if I draw something that's not exactly to scale, what if I make this side 1? And remember, the area is length times width. So if I made this side 1, and this 48, 1 times 48 is 48. And since I already made this 1, I have to I'm multiplying 1 times 36 to get 36. So there's one option. And then it might make sense, if you remember the two numbers that you multiply together are factors, maybe I can make a list of factors for the 48, and I can make a list of factors for the 36. I get 2 and 24, 3 and 16, 4 and 12, 5, 6 and 8. I skipped 5 because it doesn't go into 48 evenly. 1 times 36, 2 times 18, 3 times 12, 4 times 9, and 6 times 6. So notice I used 1 as my shared wall. So now that you can see my list of factors, it turns out we can use 2 as a shared wall, and 3 because they both have a factor of 3. And and 4 and 6. And then I look at the list to see if there's any other numbers. Yes, I see a 12. So that kind of goes with my hint of there are 6 possible dimensions. Okay, so if let me change this to 4. Oops. If I decided that the shared wall was going to be 4, right? Then I have to raise this. That means this dimension is going to be 12. And that means this dimension is going to be 9. So you can see the idea of how every time I change the shared wall dimension, the other two numbers have to change as well, because I'm multiplying each time that width times the length of each turkey and chicken area. Okay, so here's the idea. Farmer Fred, now he wants to save money on fencing. It's hard to be a farmer. He's going to use an existing wall, so it looks like a big red brick wall, right? It's on one side of the pen. What dimensions of each pen would he want to use use the least amount of fencing as possible? And so if I actually try to draw something a little more to scale, right, that first example that we drew would actually look something more like this, where this is 1. And let's make this 36 plus this is 48 feet. So notice the fencing that I would need to get. This was the big brick wall, right? I'm adding 48 plus 36 plus 36 plus 48. Oh yeah, and then there's one more 1 there, right? So I have to add all of those 1, 2, 3 sides because this side is fixed. That gets kind of expensive. So then if I just start looking at, well, hey, what are all the numbers that he's using inside? It makes sense that the least amount of the numbers in the parentheses means that the other 3 walls get smaller as the side of the wall that they share gets bigger. Oh, that's interesting. So what if I do this? I do 12 and 4 plus 3. So 12 times 4 is 48, 12 times 3 is 36. That means this side's 3, this side's 4, this side's 12. So now I only need 7 plus 7 is 14, plus 12 is 26. I only need 26 feet to cover the fence. And this one was over 140. So, and then that 12, that's interesting. I'm going to go back to this list. Remember when we were finding greatest common factors? All the factors that are circled, but the greatest common factor is 12. So he can use the least amount of fencing if the dimension that he chooses for the shared side is the greatest common factor. That's what we're going to be looking at today, and that's kind of what I want you to think about as we go through and try some of these problems. Okay, so now I'm asking you to factor the expression using the greatest common factor. So we could just make a list. If I start making a list right now, I get 1 and 35, 5 times 7. There's no more. 10 is 1 times 10, so I'm just using my my t-chart. because it keeps my numbers nice and organized, and then I can see there's a 5 there, there's a 5 there. That's my greatest common factor. Oh, but there's something else I can use. Remember when we did the 2, 3, 5, 7? Hopefully you recognize these as the prime numbers. We also learned that we could divide two numbers at the same time by primes. So I'm going to actually put a little factor ladder here, and I know 35 and 10 are both divisible by 5, and I have 7 left over plus 2. Ooh, okay. And then when I look at the 7 and the 2, they have no more common factors. That's how I know 5 is the greatest common factor. It's the only factor on the left. Now what I'm going to do is I'm going to put these in parentheses because this is the width and this is the length. So what I did was I rewrote the expression to show the dimensions. This is the length, there's the width. Now the whole equation is showing me that 35 plus 10 is the original area. That's equivalent to 5 times 7 plus 2. Now you can check your work by doing some mental math, right? 35 plus 10 equals, now I'm going to do the distributing, right? 5 times 7 plus 5 times 2. And then when I do the math here, I get 45 equals, ooh yeah, this is going to work, 35 plus 10. That equals 45. Check. Okay, let's look at another example. This time it's 28 plus 14. I don't like making a list of factors, so I'm going to keep using my factor ladder because I think it's pretty simple for me. I notice that both of my numbers are even, which means I'm just going to divide out by 2. I get 14 and 7. I look back at my list for another prime number to divide out, and I see I'm going to use 7. I get 2. Oops, I forgot the plus. 2 plus 1. I always keep the plus or the minus so that I don't forget it. This goes in parentheses. Now, this one's a little bit different. I have two common factors. Remember that you multiply them together to get the greatest common factor. 2 times 7 is 14. My expression is 14 times 2 plus 1 in parentheses. Now my equation is, go back to the original area, 28 plus 14 equals 14 times 2 plus 1. I'm going to check my work, and I'm going to make sure that the left side really does equal the right side by doing the distributive property. 28 plus 14 is 42 equals 14 times 2 plus 14 times 1 equals 28 plus 14, which, yes, equals 42. Cool. All right. Next, this is the OYO, so I want you to pause this and try these on your own, just like we did on the other examples. I'm going to write down the primes, 2, 3, 5, 7, 11. I'm going to divide by 3, and I get 9 plus 6. Divide by 3 again, I get 3 plus 2, put parentheses around that, circle my factors, multiply them, the greatest common factor equals 9. My expression is 9 times 3 plus 2. My equation is 27 plus 18 equals 9 times 3 plus 2. I'm going to check my work. 27 plus 18 equals 9 times 3 plus 9 times 2. Mental math, 45 equals 27 plus 18, which of course also equals 45. Check. All right, next example. Divide by 2, 3, 5, 7, 11. I'm going to divide out a 7. 7 divided by 7 is 1. 21 divided by 7 is 3. No more common factors. I can stop right there. My expression is 7 times 1 plus 3. My equation is 7 plus 21 equals 7 times 1. Oops, I was starting to do my check already. 7 goes in parentheses times 1 plus 3. There's my equivalent expression. 7 plus 21 equals 7 times 1 plus 7 times 3. 7 plus 21 is 28. 7 plus 21 is 28. Check. All right, so now I want to show you that really factoring is the opposite, right, of distributing. When we were distributing, we were multiplying and making groups. So for instance, when I did this, 2 times 4x plus 1, we first made 4x plus 1, but then we made another group of it. So we were multiplying the 2 times everything. So now we're working our way backwards because we are trying to factor. And so I want you to see that what I have here is 3x plus 6. If I go and do a factor ladder, it's going to look a little weird because you're not used to seeing variables in factor ladders. But I want you to know, oops, well, I don't know why I did the 2 on the outside. I want you to know that the idea is I'm still making groups of things, but this time, when I look at the groups that I'm making, oh, wait, if I see the tiles right there, I realize, oh my gosh, look, I can make 3 equal groups. And this is 1x plus 1 plus 1, which is 2. So when I use my factor ladder with a variable, I'm going to divide out a 3. And if I'm taking 3 x's and dividing them into 3 groups, there's 1 x in each group, which is why I still have a 1x, right? 3 divided by 3 is 1, but the 3 is telling me that there's 3 of these tiles, right, which stand for x. 6 divided by 3 is 2. So when I factor this, there's my remainder, and I put the 3, there's only one factor, I put the 3 on the outside. So here is my expression, and this is what it looks like with my algebra tiles, right? Because I made 3 groups of x plus 2. And then I could go ahead and distribute it to see if I get back where I started, and yes, 3 times x plus 3 times 2 is the same as 3x plus 6. Okay, so here's one that's a little more complicated. This is why I don't like using algebra tiles for bigger numbers, but it certainly helps you see what's happening. And so I'm going to just, oops, I'm going to write that down here. I'm going to do a factor ladder with my algebra tiles, remembering that even though it's weird that there's a variable in here, I'm splitting 12x into groups of 2. Into 2 groups, which means there's 6x in each group. So every time you see that x, just think of it as something that you're grouping. And now we're ungrouping it, and it was multiplied, and now we are making groups. 6x divided by 2 is 3x, and 2, okay, whoa, this is going to run off my page here. So I get 1x minus 3 left over in parentheses, and I have 2 times 2 times 3, right? 4 times 3 is 12. So my common factor that's on the outside is 12. So I can make 12 groups of 1x minus 3. Notice that I kept the minus sign each time. So now I just want you to see, hey, there is one of my groups. There's a group of 1x minus 3. Here's another group of 1x minus 3. So it's not strange that I still have an x inside the parentheses instead of a number, because that x stands for the algebra tile that I'm breaking up into equal groups. Okay, so here are your steps for factoring expressions. Go ahead and pause the video and write this down. You need to find the GCF of terms inside the parentheses. You can use the factor list method or the factor ladder method. Divide each term inside parentheses by the greatest common factor. And then remember the greatest common factor is the multiplier. It's on the outside. And then the remaining terms are written inside. Okay. So now we're going to do a couple of examples together where we're finding the greatest common factor of these two terms. It's a little tricky. Now you're going to see a variable, but I still am going to be dividing and making equal groups. So first thing I'm going to do is divide by 2. 16 divided by 2 is 8. I always put the plus because there it is. I don't want to lose that. It's 12x. If I take 24 tiles and break them into 2 separate groups, I have 12 in each group. Divide by 2 again, I get 4 plus 6x. Divide by 2 again, I get 2 plus 3x. 2 and 3 have no more common factors. I put that in parentheses. I circle all the numbers on the outside. I'm multiplying them together. 2 times 2 is 4, times 2 is 8. The greatest common factor equals 8. So I have 8 times 2 plus 3x. My equation is the original area that I was given, and it's equivalent to 8 times 2 plus 3x. If I want to check my work, because I can't add these together, there's nothing really I can do on the left side, so I'm just going to show you the right side. I distribute, right? I'm going to do the distributing. I need to do 8 times 2 plus 8 times 3x. 8 times 2 is 16. 8 times 3 is 24. Guess what? It matches the left side. Okay, here's one more example. I will divide by 2, 3, 5, 7, 11. I'm going to start by dividing by 2. 6x minus 2. Divide by 2 again. 3x minus 1. Put the 3x minus 1 in parentheses. Circle the common factors. When I multiply them together, I get the greatest common factor. 4 times 3x minus 1. It's super easy, right? Factoring is just the opposite of distributing. So my equation starts off with a 12x minus 4, and that's equivalent to 4 times 3x minus 1. To check my work, I'm going to do the distributing on the right side. 4 times 3x minus 4 times 1. Group the 3 times 4 together. I get 12x minus 4. It definitely equals the left side. All right, cool. Now this is the OYO. You get to try these on your own. Go ahead and pause it, write them down, and I'll show you the answers. Divide by 3. I get 9k plus 3. Divide by 3 again. I get 3k plus 1. Put this in parentheses. Circle the common factors. Multiply them. The greatest common factor equals 9. My expression is 9 times 3k plus 1. My equation is back to the whole area. It's equivalent to 9 times 3k plus 1. When I distribute the right-hand side, I get 9 times 3k plus 9 times 1. I group those together, and I get 27 of those k's plus 9. It works. And the last one, let's start by dividing by 2 because they're both even. I get 15 plus 12b. They're both divisible by 3 this time. 5 plus 4b. Put that in parentheses. I don't have any more common factors. Circle my common factors. Multiply them together. The greatest common factor equals 6. My expression is 6 times 5 plus 4b. My equation is 30 plus 24b equals 6 times 5 plus 4b. I'm going to check my work on the right side and distribute to see if it equals what I have on the left. This is 30 plus, group those together, 24b. Awesome. Okay, last thing I want you to see is which expression is not equivalent. Hey, if you have a bunch of expressions that need to be simplified, you just do the distributing. So 2 times 8 is 16x plus 2 times 12 is 24. Now, if you are still making mistakes, I did some mental math, right? If you're making mistakes, then you need to write this out every single time until you don't make those mistakes and forget to distribute. 16x plus 24. This one is 4 times 4x plus 4 times 6. Associate those together, I get 16x plus 24. The next one is 6 times 3x plus 6 times 4. Associate those together. Oops, 18x plus 24. So that one is not equivalent. I can stop right there and circle it. That's the end of the lesson. Good luck with Farmer Fred.